Hey guys, back with another interesting video. Let's quickly jump into this. The problem we want to solve here is majority element. Given an array of size n, find the majority element that occurs more than n by 2 times. So you can take it as a probably an voting model question also, where there will be some x candidates whose votes will be named as 1, 2, 3, 4 like that, and we have to find the winner of the election. So it's pretty common question which we get most of the time. So this has many solutions which I know is brute force method. One is like looping twice, brute force approach, which is going to be O of n square, and next one is sort and find the median kind of problem, which is also going to be O of n log n. So third model will be hash map model, where you push all of them into an hash map, and it's also going to be O of n with an space complexity of O of n. So which are very good algorithms, which are very feasible most of the time. I found an interesting algorithm which can solve it in a very faster way, which is going to be O of n with no space complexity, like O of 1 space complexity. So no extra space has been used except for the count, a small variable. So it's gonna be working fine. So method which I am going to explain you today is Boyer Moore voting algorithm. So I think very few of us knew this. I'm gonna I'll just walk through the algorithm. I'll provide you the link for the algorithm too from Geeks for Geeks and some other site, and I'm gonna explain you the algorithm. So basically I'll take an array which I'm gonna show you with example 1 3 1 3. So you can see that there are 5 elements here. Whichever element occurs 3 times is gonna be the majority element. So initially we'll start off with count and candidate, which will be set to 1, and candidate will be the first element, that is 0th index, or else you can store it as 1 itself. So if the next element is equals to the candidate, you're gonna increment the count value, or else you will decrement the value. So when you see here 3 is not equals to 1, so count will be made as 0, and the new candidate will be made as 3, so the candidate will be 3, and then when you go to the next one, it is equals to candidate, so you're gonna increment it. So 0 is incremented, so no, it becomes 1. Sorry, my bad. It's 1, as when it is changed as candidate key, you change it as 1, and 3 will be the new candidate. So again, when you check to the next element, 3's candidate keys matching with the next element, so count will be obviously incremented, and candidate key won't be changed. When you go to the next one, it makes the count will be 1, but count is still is not equals to 0, so the candidate still remains the 3. So when you go to the next one, so it's gonna be count will be incremented and becomes 2, and the candidate will be 3. So the final candidate will be returned as the majority element. So you might be wondering, so this guy bought us some array for which this algorithm works. Oh, why does it work with everyone? So even I had the doubt when I saw the algorithm. So it's pretty obvious. So what basically has been done here? So when you take an array of n minus n elements, so what the basic thought here goes with is, like, whenever you find the element, you're gonna increment the count. So basically what it you'll find initially when I showed you the question, you might have observed that the majority element obviously exists in it. So if it doesn't exist, you won't be able to apply this algorithm. So then you have to make sure that this will have that more than n by 2 number of elements array. So what basically the idea is, whenever you find that majority element, you're gonna increase it. Other than that, if anything is there, you will decrement it. So you may be asking me, like, what if all the elements lie the other side? So So basically the thought here goes as, like, whenever you find the similar ones, you're gonna incrementing the count. Whenever you're not finding the count, you'll decrement the count. So basically whenever you go with greater than, count will be incremented and so on, like 1 2 3 and so on. So we said that there is an element which will be greater than n by 2 when you take, whenever, even if you take or even number of elements or odd number of elements, it's very sure that this dominates the array. So the majority elements will be more than the all other elements, so none other element will have a count of positive by the end of array. It's very very particularly sure. So whatever array you take it also, let's go through some technique what you felt. 1 1 3 3. So here also you'll start off with count as 1 and 1, so you'll increment count as 2 and still the candidate key will be 1. So and then also you'll, like, you go here, so candidate key count becomes 1, still the candidate is 1. So here it becomes 0 and this will become the new candidate key and count will be 1. So this will be with the candidate key 3. Next one 2 and 3. By the end of this you got the candidate key. Let's I showed you the first method. What I show was 3's will be the middle, I guess, or else let's take 3 3 1. So here also it starts with candidate key as with count 1 and candidate key 3, 2 and 3, candidate key 3 and 3. So here you will decrement 1, so this becomes 2 and still candidate key is 2 3, sorry. Here also it decreases candidate 1 count and still it's not equals to 0, so you don't need to change it, and candidate key is 3, so by the end of it also it returns 3. So it best the thing works is there is some complexity. You should, like, probably think in once. So what basically this algorithm says is, if similar elements are found, it's gonna increment the count, or else it's gonna decrement the count. What if someone asks me, like, what if they are in, like, in 1 3 1 3 3? So yeah, I even faced this kind of question, but the tricky answer what I get was, however you place the elements, you're gonna have at least two elements when it's gonna be major element. When the majority element is greater than n by 2, you're definitely damn sure at least one of them has to be in consecutive. Otherwise, like, see, when you have to place them in 1:1, like no consecutive places also, then because it's greater than, it's dominating it, so you'll definitely have it. So I think I clearly explained algorithm, so I don't have much more things to say about it uh, in mathematical way or anything. So I think it's clear. Thanks guys, thank you very much for watching this patiently.